How do you prevent the ledger from becoming too large with 1,000 transactions per second? Will it be many terabytes of data in the future? Inevitably, you will converge to a situation where the blockchain basically becomes too large to be a replicated artifact. This is one of the fundamental failings of Bitcoin, and one of the reasons why Bitcoin Core is trying to keep the block size as small as possible, because they understand that if the block size gets too large, too much goes on chain, you lose a property called inclusive accountability. So inclusive accountability is this idea that everybody has the capability, at least in principle, of checking each other's homework. So you can look at the blockchain, I can look at the blockchain, we can go through the whole thing, and I can verify the same level of veracity and truthfulness as you can. If you get to a situation that only one actor can have that entire history, then you start losing that property, that inclusive accountability. You no longer have the ability for everybody to check each other's homework. Now, there are things you can do to get around this, and you have to do all of the above. So 3 things. 1, you want to treat the resources of the blockchain as a precious commodity. That's what Blockstream is doing, but I think they've gone too far. I think Bitcoin Core is hurting their ecosystem by restricting their block size. It should grow, and it should grow at a reasonable rate. And they're like real-life metrics that are kind of like the Moore's law equivalent of network capacity and storage. And I even told Adam Back this. Nobody listens to me. That you can, I think, use to create a model to allow the block size to gradually grow over time. Just like we have other metrics like the Bitcoin halving, for example, which is another bad design. You never want to build a system where you have a dramatic event that makes everybody lose half their money for profit. It's like, why would you design a system that have sudden drops? You should have a continuous curve instead of a discrete step function. But anyway, getting back to it, 1, you treat it like a precious resource. So how we do that is saying, the base ledger has a lot of capabilities, but then take a lot of the stuff that is lower economic priority, like microtransactions or high frequency stuff, and push those things into level 2 solution. I think there's wisdom there as long as the level 2 solution is censorship resistant, has the same privacy guarantees, and is also open participation. So Hydra mostly accomplishes this in its design. Okay, 2, you need to use fundamentally different cryptographic primitives to secure your system. In particular, the concept of a snark, recursive snarks are great for this, where instead of saying, show me everything, you say, show me a proof of what you've done is legitimate. And all I need is to check what you've done against the proof. And if I have just a little bit of information, I know it's great. So the project that's pushing this the heaviest is called the CODA protocol, CODA. And they're trying to implement Halo. But Zcash has come up with some ideas, and we're actually working on these ideas at IO Research. And it's beginning days, so it's not like we have a final solution yet, but it's a super important thing. Now, the advantage here is that these proofs are independent of the size of the shared state. So you could have a massive UTXO, you could have a massive blockchain, and you'd still be able to use the system with these proofs that are very small, like megabytes to kilobytes in practice, and with the same level of security as if you had a petabyte of data. So that's absolutely amazing. 3, you have to move from a replicated system to a distributed system, to a decentralized system. You have to distribute chunks of the chain to many different people, and you have a shard of the data as opposed to the whole thing. And you can always reconstruct with high availability guarantees anything you want on demand. You have to do all 3 of these things. And if you do all 3 of these things, your system will be pretty good. You probably should also implement some notion of economic garbage collection. It's a super controversial topic, but it's something that needs to be done. So you prune transactions out, or you prune dead currencies out, or things like that. But you have to be careful about how you do that. It's why we didn't, for this 5-year contract, decide to do that. We wanted to have a community for the next 5 years to have that discussion with, to figure out the optimal solution and try to make it an industry-wide solution. But if you can do those 3 things, then you'll have a sustainable system, because you can grow to any size and anybody can use it and have inclusive accountability. You can grow to any size, and any piece of history you're interested in will be available on demand, And there's some economics behind that to make that possible. And you can grow to any size, but your growth rate is not stupid because you're emptying garbage and you're also not putting bloat on the chain. You're putting economically essential things on the main system. So that's what you have to do if it gets to petabyte size. It's not simple. No protocol does this. None. Zero, zilch. It's a super hard problem, and it's a multidisciplinary problem. You have to have miracles in data structures and miracles in distributed systems theory and cryptography miracles and a lot of network work because you're talking about a network that's going to be moving a lot of data. So it's a hugely ambitious context. The kind of thing I would love to solve over the next 5 years, and we would have a gargantuan competitive advantage over everybody else. And that's what would get us to 1 billion users, or at least give us the ability to service 1 billion users. Thanks for the answer. Number 2, do you still need number 3? Yeah, you do, because just because you can verify that what you're seeing is right, because you're talking about an enhanced transaction, which may have smart contracts and an embedded legal DSL and metadata and other things, you'll know that 2 properties are preserved. One property of existence, so the existence of the token, so the asset you're looking at does exist, and 2, that it hasn't been double spent, the non-existence of a double spend. You can prove those 2 things with a zero-knowledge proof, but it doesn't show you the history, which may be relevant for an out-of-band regulatory scheme or things like that, or compliance requirements. This is especially true with security tokens. So you need the ability to recall information on demand so that high availability is required. And also, it's just a philosophical thing. It's like you're going to throw history away, but this is economic data. It's very important to preserve it. That's what Satoshi was right about that.